Right. So, hi everyone. Thanks for joining today's seminar series organized by the Empathic Computing Laboratory. I'm your host, Pai, and our guest speaker for today is Albrecht Schmidt, who is currently a professor for human-centered ubiquitous media in the computer science department of the Ludwig Maximilian University of Munich, or LMU. His research interest is on ubiquitous computing, context-aware computing, and implicit HCI. The title of his talk is Interactive Human-Centered Artificial Intelligence, a definition and research challenge, which is about defining interactive human-centered AI. The talk will be about an hour, and then later on we'll have a brief Q&A session, about 30 minutes, where you're free to share your thoughts with Albrecht. So without further ado, over to you, Albrecht.
Thank you very much, and I'm really excited to be here, even if it's just virtual, but I'm really looking forward to have some discussions with you on that topic, which I think is driving a lot of our questions in our research at the moment. And I will start with sort of the question, who is in control of what you think? And let me start with this. So, let's see, that works. So, and I think this is a very serious question. I think over the last years, it got more and more closer to myself. Who decides what you know and what you believe? And as I said, it's interactive, and I think we have a chat. Who decides what you know? Who has decided what you know? And I'll see if I can open the chat. I'm not sure where it is. So don't be shy. Who has decided what you know? Google? If you think earlier where your roots are, who has decided what you know? And I think the social network, I think in this case, is not the social network like Facebook or Google. I think it's much earlier what your beliefs and your knowledge is. It's basically the people who teach you. It's your parents at the very beginning, and they make you sort of know things, and they create your reality. And I think once you have children yourself, you really realize that you can create whatever reality till a certain age. And so it's an interesting thing. So there is a reality out there, and we talk later about realities we create technically. There is a reality there that is part of your home, your parents, your religion, your beliefs, the school you go to, the academic environment. And this becomes your reality. And now the question is, who decided what your schools teach you? And I have seen this for Germany. This is a quite tricky process, and it's a process there's a lot of fighting over what is in the national curriculum. And I think that's probably in other countries as well. So what do you teach children? There are so many hours you have. What do you teach them? And I think this seems quite far away when we talk about virtual reality, but it's really important to understand, because I think the people who decide what you know, what you believe, they are the ones who are creating your reality. Because reality is not something that's sort of undisputed, what's fixed, what's there. And I think we have seen this sort of on the, from the outside, more nearly funny what in the US happens with alternative truths. And that's not what I mean. I really think the way we see reality is a really deep question, what reality means and how we take in reality. And I think very much pictures create our reality. Our visual system, we look at things, and the things we look at, we take for real. And I think probably 25 years back, most of the pictures you saw were real. By now, most of the pictures you see are digital, and especially in this current situation, a lot of the reality we take in through digital channels. And now basically we come back to this, who is in control of those digital channels? And I think this will be the central question I'm going along, because I think with a lot of the things we do in augmented reality, in virtual reality, we are at that point where we control people's reality. And this is an extremely powerful situation. That's also why a lot of companies investing a lot of money in that space. And let me take one other step into a different direction. What is a cyborg? I think if we talk about control, the cyborg is really sort of very close. And very often if we would look for the term cyborg, and this is what I did here, this is just a Google image search, and I picked the nicest ones. So we have very often this feeling that a cyborg is really far out, that it is very futuristic, that it's really this question of how we get people together, and sort of it's a cybernetic organism. But what is this? And I think, do you have definitions? And I think if you speak another language than English, what is the word for cyborg? We have, if you Android, it's and I think Neil Harbison, that's the guy who is here with the sort of looks like this camera where he gets sort of different color images. Other people have also said people who implanted themselves a microchip, which can be read out, is sort of an external, is a cyborg. You could argue somebody who has a hip replacement is a cyborg, or does it need to be digital? And I think if you look in many of the richer societies, if you get old, you have a lot of replacement parts. And so I think the control question is really, I think, central to the question whether you're a cyborg or not. And I think humans who have been modified by technologies to increase their capabilities. If you take this wide definition, it's really not necessarily what is the body modification? Is it really something that goes inside? And I have one question here. Are mobile phone users cyborg? Is a mobile phone user a cyborg? They get a lot of those things. They have enhanced human capabilities. They, through technologies, I think they experience sort of modifications. And I think the question of the extension to the body, is it really invasive? Do you have to put it inside? Does it make a difference whether you wear something or you don't wear it? It's inside yourself. And I think some people argue that fusion and symbiosis is important in the chat, but I would also say the question, who controls you? And I think I give you a scenario. Assume I have people in a certain place and I want to get them somewhere else. I could use a mobile phone to do that. And I think in Germany, I explain you how you would do it. And that's a really important German word, Freibier. It's free beer. Imagine you have 100 people in a space and you just tell them on the space 300 meters further down the road, there is free beer. You get the crowd moving. And I think this is, in a way, you could do this much more subtle. I think you could send people messages, and by this you slow them down. We looked into crowd control. If you send people a message, they just pick up their phone, they will get slower, things like this. So you have already a lot of power over controlling people, even so the phone is very much on the outside. And so I think this question of what makes us a cyborg is sort of a VR headset, is an AR headset already sort of there. And also the question, who is taking control of what we are doing? Who can steer us? How can these devices steer us? And I go into more detail on this. And at the moment, we have very much the mobile phone that's controlling us. But I will show you that this is going to change very rapidly. If you look at smart devices and the Internet of Things, those are predictions and they are still pretty much on target. At the moment, I think most of us probably have 1, 2, or 3 mobile phones and perhaps one or the other smartwatch. But I think medium term, we will really go further and further down that road where we have many devices. And I think, and these devices, they are run by software, and these devices are not just wearable devices, they are whole homes, they are cities, they are industries. And so your city can really control you once it is sort of an Internet of Things thing. And this is sort of where you really, have to decide whether you find it exciting or frightening. I think it is probably to some of us both, as there is a lot of potential for control. So basically, can you get into a building, get you out of a building if the system decides? That's real reality. That's sort of changing your reality, changing your abilities in the real world. Things like traffic lights in smart cities, again, sort of changing completely what you can do or what you can't do. And why do I put this into the context of virtual reality? Because I think at the moment, we think very often when we think of augmented reality, mixed reality, virtual reality, we think of very much the glasses we wear and where we overlay things. But just imagine all the things we have in our everyday life. They become smart. And I have a picture here. This is a really nice book. I really enjoy having it. It's by Paola Zuccotti, and she is an artist taking pictures of what people touch during a day. And you can guess while looking at it who that person is. And you could argue this is something like the view Amazon has on you, basically the things you own. This is sort of if your online shops, they know what you have. And now imagine each of these objects just have very simple sensing inside, that it knows when it's used. And then imagine it has very simple actuation, so it can sort of either sort of tell you something, that it's just that you forgot it, that you should use it, etc. And I think at this point, our reality becomes very different from what we know nowadays. And the core thing with AI is it will be part of everyday objects. And I think we teach, for example, a course on smart objects, on creating intelligence objects. And what is going to happen if you have intelligent objects? They want to compete for your attention. They want to nudge you in a certain way. And I think if we look at conferences like Kai, there are a lot of papers on behavior change, etc. So this question, it is really moving away from the single device we can wear, AR glasses like the mobile phone. It is really imagine what would happen if all of the devices around you have very similar capabilities of those technologies we develop at the moment as the wearable single technology. And at the moment, you could really imagine taking off your AR glasses, but once it's in every part of your environment, you're just really locked into this. And this is sort of, the world we are thinking in our research. What happens if really we are surrounded by intelligent systems that are networked, and the question how we control them, how we keep the user in that loop. And I have in the introductory part one final term, intelligence. What is intelligence? And I think intelligence is very often linked to intellectual capabilities, to your cognitive abilities. And depending on the culture you come from, the school system you come from, you may have done intelligence tests at some point, these IQ tests. And I think there is something interesting, even so IQ and definition changed, but one of the fundamental definition is half of the population is below and the other half is above. And whatever you do, so you can compare it historically, and people argue it moves this way. But I think at any point in time, you have sort of this Gaussian distribution, and there is not much change in this. And now the question is, when we measure intelligence for people, that works fairly well. It is disputed, but we can measure intelligence for people. But can we measure intelligence for systems? Have you seen any measure that gives you an intelligence measure for a system? the Turing test. That's an interesting one. That's comparing it to the human in a way. And I think for us, this is really one important question when we design intelligent systems, especially for human use. This question, how can we measure how intelligent an artificial intelligence is? And so far, there has been no real idea how to do that. There is some discussion, and I think one of the fundamental takeaways is as long as we cannot measure it, we probably cannot seriously arguing that we can develop artificial intelligence. At the moment, all the measures, and I think some of you are working on SIGGRAPH papers, a lot of the measures we see at the moment are, I can do better on a data set. But this is very far away from being intelligent. And so for us, one of the questions that arises from this and where we work on is, can we measure the joint performance for a task of a human together with an artificial intelligence? So let me go into detail. So there is one area, and we had today a workshop where also Jim Crawley talked about chess. And I think chess is an interesting thing because it is humans can do it, machines can do it, and we can typically measure a lot of it. And if you look back, I'm not sure who of you is playing chess. So only 25 years back, it was quite controversial when a computer won against a human because people felt the computer shouldn't win. But I think only 10 years later, so 2006, it was very clear that computers win. And I think by now it is very clear that computers win. But we still know who the best chess player is. And typically we don't mention a computer, we mention a human. And I think it's very similar to, we know who the fastest person is running at the Olympics, even so that person is massively slower than a granny on a motorbike. So I think this is something we learn to separate things. And I think for chess, this holds one of an interesting dimension when we talk about joint performance. And this comes closer to the Turing test in a minute. So there is this notion of cyborg chess, of freestyle chess. And it's the idea is you have a team of players that have all the computing power they want, playing another team of humans having all the computer power they want. What is the outcome? And this is again sort of it's inconclusive. Some people argue they have no chance against a computer. Some people argue it's a much more interesting game if you have the human in the mix, because you can do more surprising things. And I think this is sort of the jury is still out there, but we can generalize this to a question I seriously put forward to you. And I think we take a minute to discuss this. So the question I have here is, can we make technologies that make us observably more intelligent? And I think that's a very clear yes. And now let me explain you my sort of thought experiment here. I have a question, and here I have a human with no augmentation. So imagine you have a person, very clever, well-educated, but no access to the internet, no device, no augmentation. Here I have a person, sort of average educated, able to read, with augmentation. And for sort of the sake of the argument, let's take a very simple augmentation. This person has an internet connection and an iPad, and this has nothing. What questions can you answer that this person wins? This is the easy question. So you have here the person with the iPad, here without, and what questions can you ask this person will be much better at? Knowledge questions. And I think you would come up with hundreds of questions, very specific questions you can ask where it's very clear the person with augmentation is better. So this says, yes, we can create technologies that make us on an observable level more intelligent. Now comes this side. And try to find specific questions, not generic questions, not groups of questions. What would be specific questions where you would feel that this person has an advantage over this person? I think there are a number of interesting things. How can I enhance better my intelligence? I think the question is, if you have somebody who Googles that, they may come up with a paper or two, which basically has evidence how to do this. Personal memory is an interesting one. If you have your personal memory and you ask that person about their personal memory, they may have an advantage, but you could also argue a lot of our personal memory is outsourced in our Facebook stories, in our Instagram stories. So we may have an advantage here. I think the question about art, that's a really interesting one. And there's a lot of argument that this requires a human. Personal question, what would be these personal questions? Perhaps something about what they like, what they don't like, about feelings. And obviously you could ask the other person that as well. And I think thinking about this, there is a slight trick question in this, because this person, and I think Kunal asked this, let's assume this is the same person if we can replicate the person. That's really hard for an experiment, but I think if you think, so that the trick question here is, obviously it's the decision when to use augmentation and when not, because this is still the human. So obviously each question that is answered on this side could also be answered by that person by just leaving the iPad out. And I think this is another important message to take away. I think this question, how we design that we can make choices when we are the better person to give a solution than the technology. And I think we haven't focused on this, because I think we've typically, and I think people realize this. And today, I said it earlier, we have been writing exams, and they were designed in a way, when you start Googling, you will lose so much time that you will not pass, because we had to do it remote. And so we put the questions in a way that they're really hard to find online. And that when you don't know it by heart, you will have sort of a disadvantage on time. And I think this is one of those things. When do I use no augmentation, and when do I use the augmentation? And I think the question about life going in the, I think the early augmentation is writing. I think this is something people have been writing. And the same argument we see at the moment for AI, you can find in Greek literature. And the argument goes basically like this. If you start writing down, you lose the ability to memorize, because you don't see the point in memorizing. And there was a big, 4,000 years ago, there was a big dispute if scholars should write or not, because writing will corrupt your memory. And it does, obviously, but history has told us we would never have arrived where we are if we would have relied on our human memory. And now we come to this point, how can we enhance our cognitive abilities, and where will cognitive enhancements be hard? And I think this is this question, what are the low-hanging fruit? And the overall goal here is to design human-machine systems that are better than the human without the machine, but that are also better than the machine without the human. So, and this is a really hard thing. And coming back to the questions we had earlier, so really, if you take off autonomous driving, so this would mean an autonomous car is worse than a human driver. And it also would say a human driver without assistance of the system is worse than an automated car. So you want to have something where you get both together and you can outperform both. And I think this would be, for me, also a gold standard if you want to publish something where you say it's truly joint intelligence between human and machine. You have to show you can outperform the human who doesn't have an augmentation, and you can outperform the optimal machine for the task. Because if you cannot outperform the machine, it doesn't really make sense to have the human in the loop. And if the human without augmentation can do it better than the system, you should not design the machine. So I think that's important when we think where to apply it. We really have to find these things where the human machine system is outperforming this. And this brings us to a lot of related work, and it's not as new as a lot of people argue. If you read Vannevar Bush from 1945, as we may think, that sort of inspiration for the internet. If you look at Licklider's PhD thesis, Man-Computer Symbiosis, Douglas Engelbart, and I think this is a really interesting research proposal, augmenting the human intellect, and later Mark Weiser or DARPA's augmented cognition. So those are ideas that augmentation, not automation, or towards amplification will really change what humans can do. But this relies on that we find things where the human and the machine, the human and the AI together are better than either alone. And the motivation why this is now interesting comes from two directions. So one of the directions is the more theoretical side. So we have now understand in psychology the extended mind, externalization of information, of content. And I think a lot of things we have seen in the area of augmented reality is really working on extending our mind into the environment, distributed cognition, group cognition, again, things we have been seeing in systems people have built. And also the use of space. I think very early work also, if you look at Mark's early work, he did during his PhD, really putting things into space, very early ideas of this. And I think we have understood it from a psychology perspective, and now the systems can be built. And here comes the technology push. What we see, we can build sensing and capture systems that outperform our own eyes, ears, and other perception. We have advances in processing, and we have now, we are at that point where embedded presentation, where augmented reality, the classes are just about to be there. It may take another 5 years, it may take another few generations of those devices, but it's not something like which is in the very distant future. It is not that far away. And I think with this, we have talked now about sort of the concepts at the beginning, which sort of feed into this. And now I want to go into what does it mean to have interactive human-centered artificial intelligence. And I will start with a definition. The definition is an interactive human-centered artificial intelligence is an artificial intelligence that enables interactive exploration and manipulation in real time, and is designed with a clear purpose for human benefit while being transparent and about who has control over data and algorithms. So it's a very sort of lengthy definition, but we try to sort of shorten it wherever possible. But I think there are a lot of parts in there that are really important. So it's about an artificial intelligence, obviously, that is interactive and allows exploration and manipulation in real time. And it should also have a purpose, and this purpose should be beneficial for humans. If it's not, it doesn't really make sense. And I think the last part becomes more and more important, that we understand who has control over it. And that brings me back to the very beginning of my talk, that our reality is more and more created by artificial intelligence, be it, and I think you can take very simple examples, your Google News feed, and some people said this is how many of us see the world. This is a very stupid algorithm. If you look at it, it's not a very advanced algorithm, and it basically creates your world perception, or it has a very strong impact on your world perception. Now think this into the future. So it's really important, what is the interest of the people who control data and algorithms? And we have listed 8 properties that come out of this definition. And I think it's that we can interact in real time with the algorithms and models. And this would mean for the Google, if you take the Google News feed, you would be able to say, I can change the algorithm in order to explore what happens. And that's also the second point. I can see if I say, if I'm more interested in this, if I would have read more about this, if I would be at a different location, how would this change? And I could manipulate this in order to understand the algorithms. And if things happen very fast, and this could be sort of automated driving, etc., I can reduce the speed of processes in order to allow interaction where I otherwise couldn't interact. We can interactively question how specific decisions are made. And I think that's something that starts to be available in some areas. So you can ask on Amazon, for example, why did I get this element suggested? Why is somebody sort of thinking I should buy this? I can ask that question. And so I can, but there's very often missing that I cannot really get how the specific decision has been made. And then there comes sort of the more high-level questions. And if we don't know them, we may sort of be tricked into something. And I think the question is, how do humans benefit from an artificial intelligence? And if we cannot tell how they benefit, we should not develop it, or we should not really have it. Also, what are the risks for the individual and on societal level if you build systems? Who has control over the artificial intelligence, especially who decides what data goes in there, what models and algorithms? And I think good luck trying to find that out with Facebook, how they structure their feed, or with TikTok. I think it's really hard to figure out what their sort of intentions are and what they did in order to do, to make you sort of stay there. And I think it's also the last point related to that, what data, knowledge base, and information is used to create and inform. So basically, what information was used to train the system so that you can reason about typical biases that may come in from the data people have been using. And I think you can apply this, and I think I have it here as an example. I will not go into much detail here. You can apply this to things like the Facebook feed. And it's basically the question, can you manipulate in real time how this feed would change if you would have different information in there? You cannot. Can you explore specific decisions? I think they don't even tell you where to dig down on specific decisions. I think the risk for individuals on societal level, others have written about this, from sleep deprivation to anxieties, but it's not set on the webpage. Who has control over data? I think on a high level, we know it's a specific company, but we don't know it on a specific level. And also we don't know exactly what data they use about us in order to do that. So this is in a case very clear. This is not human-centered and it's not interactive. Hence, it doesn't fall under the definition. And we would like sort of that people work more towards making things that are good for us as a user. Now, how does this go together with a lot of the bigger questions the research community asks at the moment? And I think some people argue it's about understanding systems. A lot of the points are in there. It's about understanding systems. And I would argue our communities at the moment are not really sort of very good at this. If you look into publications, you find typically two extremes. So one is the side where people say, oh, it's really easy. We just publish the source code and everybody will know how it works. And I think for this, I would recommend to teach first-year students programming. You give them a task you know very well, and you get 100 variants, and you don't understand their code, even if it's just 10 lines long, because they may have some ideas how to program something very simple. So it is really hard to understand code. So the source code very often does not really give us understanding what something does. The other extreme is sort of that people, and I think this is an example of visualizing neural networks. And I think if you are the person who has designed the network and you have the network architecture, you typically can understand some of the visualizations and they give you a chance to improve your architecture. For the end user, those visualizations are not really useful. On the other hand, I think people are pretty good to understand what the high level issues are. And I think some years back, I think 5 years back, Microsoft chatbot was very quickly racist. And I think a lot of people understood why, because it was fed on Reddit. And I think everybody who has read Reddit understands why. If you train something on Reddit, it is very likely that it is an asshole afterwards. And so here it was very interesting to see people did not understand the algorithms at all, but they understood the data it was trained on, and they understood what comes out. So I think this is the question, and I think these are these parts of the systems. So how do we really make people understand? And I think it's not a source code, it's not a visualization, it's something higher level. And I think we have to try as a community to really understand what is the higher level information that make people aware of what's going on. So understanding the systems is something that is not solved. And I think there's a lot of open research that doesn't really sort of, that hasn't happened yet. The other question is, when we talk about control, is the level of control we are having. What level of control do we require? And here I have an example. So if you park a car, I'm not sure who of you is driving. If you park a car in 2000, you had to do the steering all by yourself. And you could park quite sort of strangely in a parking, and the car didn't really help you with parking. 2010, you could do sort of this assisted parking, and I think by now you get cars that park themselves. Would somebody argue that they have lost control over parking their car by these things? So probably most people will not argue they have lost control, because they still decide when to park and how the car is parked in a specific parking spot, or even in a cold parking garage. They couldn't care less. And so this question is, where do we give control away? Or is it just that we execute control on a higher level rather than on sort of this very detailed level? And what we see there, this is not just driving a car. I think we see this in trading stock, in unloading ships, whatever. So we have given away control on this sort of millisecond level, but typically we have created control on a higher level. And so that the granularity in which we make decisions may be increased with AI, but we may not lose control. So, and this is sort of, we argue, by designing more for agency rather than for direct control. So bringing the parking example, you want to be in control when it's parked, potentially also where, but you don't want to do sort of the detailed stuff. And I think that has been throughout human history. We have started to abstract things. So this is sort of, with a lot of technologies, we have started delegating some low-level tasks. And I think with AI, we are in that part where we move on, where we move higher, where sort of we rather have agency in relation to objects, to intelligent systems, rather than direct control. And this brings us to the point, if we have a bigger, granularity, the question is, when do we want to exercise control? Do we really want to exercise control all the time? And I think with the car, I want to park it, I tell the car to park. But as I'm arriving at the office, it is very clear that a car has to park because I want to get out. And so do I really have to tell the car that it needs to park? I think not. And that's why we came up with one other concept, which we call intervention user interfaces, where we say, we believe that autonomous systems will make a lot of decisions, and we are typically happy. So the default will be that we are happy with the decision the autonomous system makes. So we don't want to tell the system what to do all the time. We rather want to tell the system when we want to have a different decision to be made. So basically, we move from a direct manipulation, a direct interaction, to a system where we let the system do whatever it does. And typically we are happy in only the cases when we are not happy with what's happening, we intervene. And so basically we intervene with the decisions. This is sort of very much a discussion paper we published some years back in the Interactions magazine, and we're very happy to sort of get challenged on this and really cut this further. It obviously taking this more to an extreme. I think it's really interesting to discuss, do we really want to think of us as being in control, meaning that we have the burden of control all the time, or do we trust the system and we are sure that we can do interventions? And for the intervention phases, we have a set of design principles, and we link them to Snyderman's rules of traditional system, and there are the following rules. We want to ensure that you can expect what system, you can predict its behavior. You can communicate as a system to the user what interventions you have. And I give you one example what I mean with that. If you are on a train in most countries, you cannot tell the train driver to stop at the next village. I live on the weekends in a village where you have to press a button in the train, otherwise the train is not stopping in that village. And typically people who don't live there never get off the train there. They get off in the next bigger city and take the cab, because they just don't know that you could ask the train to be stopped, because this is in Germany something that's very rare. And so the interface you have is that you can tell the system tells the user what interventions they can do. We want to allow users to explore interventions. And if we have carried out an intervention and we don't like it anymore, we want to undo it, like the control set in current systems. So what would this be for interventions? And I think this is there it becomes really tricky, especially if you have physical objects that are moving. And then we want to minimize the attention required. And I think this is the key thing why we, in the first place, go for intervention user interfaces, because we don't want to really sort of have a lot of attention always dedicated to the system. And the final point is the user should be always knowing how the control is shared between the user and the person. And I think this all together brings me to this question: is AI a new tool? Is it the basis for new tools? And I think here just one thought about tools. Tools set humans apart from animals. And there's a lot of discussion in biology that tools are the things that have really sped up evolution. By us having tools and by us being able to make tools, and I think there are animals that use tools like monkeys, and interestingly, there are birds that make tools in order to achieve something, but obviously not at the level humans can do. And by our ability to make tools, we made a lot of things easier in life, and that led to a very quick evolution. And I think we see things like the tools really define what we can do. If I ask you to move sand and I give you a shovel, you're much quicker than if I give you no shovel. But if I give you a big digger, you're even much quicker than with the shovel. So the tool defines your performance. And we have seen this over the last 30 years, that the tools we have change the performance, the cognitive performance we have. And most of the things in our life nowadays, they could not be done without computational tools. This is not in the future, this is now. You could not build such a car or such a building without a computer. There would be just not enough human computing power around on the planet to do those things, to build them. So it's really interesting. We have already moved into a world where without computing, we could not, without computing as a tool, we could not build the things we have. And this brings me to the centerpiece of this discussion. Are we moving into the AI age? And I think you probably have learned in history in school, sort of the Stone Age, the Bronze Age. And now the question is there something like an AI age? And I think the interesting part is, if you look into the Bronze Age, at the beginning, it was really interesting to make bronze. And people who could do that were really sort of highly valued. But very shortly after they figured out how to do that, making bronze was not interesting. What was interesting, making things out of bronze. So could you do a nice sword? Could you do a nice shield? Could you do other things? And I think we are at the moment in AI at this point that everybody is sort of still focused on how to make the bronze, how to make the best algorithm. But I think we are soon moving on to what are the things we can make out of AI. And I think this is sort of where I guess the cards are mixed new, where new companies will come into play, where it's really how can we use AI in order to have a benefit. So it's not like making the base technology. Obviously, we have to have the base technologies, but this is sort of happening at that point. But once we have the base technology, once we know how to make iron, how to make bronze, you see sort of this huge explosion of an innovation. And I think that is my personal guess, we're just before this sort of point where this explosion of innovation happens, because the algorithms are good enough, the AI is good enough, the tools are good enough that a large number of people can use this new material to make new things. Now, is sort of the idea of cognitive tools, is it really new? And I think it's not as new as we very often think. So as I said, writing is a very old cognitive tool. Here are perceptual tools for measuring time or measuring distances, for writing, for calculating. And I think the first generation of digital cognitive tools, I think we are all used to. So like Google Maps or Google Search or a word processor. But I think what's now interesting is sort of what is the next generation. And I think I compare this very often to the shuffle you've seen. So this manual shuffle where you can move sand, but you're very slow. So what would be in contrast the big digger that moves the sand very quickly? And for us, it is really sort of this question, how do we move from the current cognitive and perceptual tools to the new ones? And that's one of the projects we work on at the moment. And we take inspiration from traditional tools that aid our perception, and there are plenty of them. And the other motivation comes from that technologies at the moment have surpassed human sensory capabilities. And this picture you see here, you can never see with your own eyes, but many of us have seen that picture. And now one of the questions is, how can we create a perceptual aid that we can control without really thinking about controlling it, that gives us the capability to see such things in the real world? And seeing is just one example we look into. And this is in the context of a European project we are running. And it's the question, can we create a new way of human reflection, human perception and artificial reflexes? And I show you one of the prototypical systems we look into at this point. So it's the idea we have a headset, and I think this is sort of our optimized, what we envision sort of in the future, how an AR headset looks like. This is an EEG, and the idea is we have EEG, EMG, gaze, etc., a lot of physiological sensing. We have a lot of cameras attached, and they may be sort of different spectrum, different resolution, high speed, etc. And the idea is, can we create now, based on things like your emotion in the face, your cognitive load, can we create a prediction model, what you want to see, and zoom or change speed, etc. And I show you one example we have been exploring over the last years. It's basically the question, can I slow down reality if I want to see something closer? And so here, this was one of the tests we did for the paper. So basically, somebody had to estimate how high somebody jumps. And basically what we did, it's a HoloLens with camera. And what we did is you could, at this point, even with just a handheld controller, slow down reality. And by this, obviously, you can better see what's happening. And sort of we want to combine this, and that's work we're doing at the moment, combining it with using physiological sensing. So let's say your cognitive load goes up because you concentrate on something, so you can slow down reality. And one of the examples we have used sort of as motivation in the paper is, you have here a bird, and this is pretty small on the screen, and this flies off and it's gone. If you have linear time, the bird flies off, that just takes a second and it's gone. And the idea what we can do now is, you look at the bird, you see there is motion, you get sort of a higher cognitive load. We slow down to a factor 10. So basically it's a factor 10 slower, so you can really see how the bird lifts off. And then once the bird is gone, we catch up in time and basically go back to reality. And then we are sort of, obviously, once you start walking in this space, it gets really tricky because your real reality is different from what you see. But this is one of the questions we really sort of at the moment explore, how we can change reality in that way, and how we can really improve our ability to recognize our environment. And yeah, you can see on the website and in the papers quite a number of different ones. So we also looked into audio perception. So the idea is, so if you hold your breath, you can hear things better. So I think we do that. And I think there's the idea, and this is sort of, it looks a bit funny, this prototype, but what it did is basically when you were holding your breath, it was focusing further out on an audio signal. And if you sort of, you just controlled it implicitly. And that's sort of what interests us, is really this implicit control to have new senses without realizing. And the hope would be that we can build something in the long term where we can use new senses without really realizing that we use new senses. And I want to sort of wrap up with sort of the question how we can use artificial intelligence to amplify our mind. And I think there's the question of how can we use predictive powers of computing? If we sort of amplify our mind, it is good to know where you go next, because we can make decisions on what you need next. If we know what you will order, we can already bring it to you. So we can basically do a lot of things. And even things like if we know who you choose as a partner in life, we can provide much more support for that. So the question is, how do we create this glass ball that can look into the future in order for us to have systems that can really change what you, what support you get, what cognitive abilities you have. If we basically try to give cognitive help in the moment, that's pretty hard. But if we know about your future, that's much easier. And there's one saying that's assigned to a lot of people: the best way to predict the future is to create it. What does this mean in this way? And I think in this way, this means if I tell you what to do in the future, and that links back to the mobile phone, if I tell you what you should do in the future and you're going to do it, it's really easy to predict your future. And I give you one example where this already happens. If you have maps, and this is sort of a map from Munich airport to our offices, and if you drive by car, there are about 100 routes that probably take equally long. Which one are you going to take? Very likely the one Google tells you to take. So for Google to predict where you go is really easy because it just tells you where to go. And there is also this understanding that a navigation system, if you explore a navigation system, it really works well if people don't know the city. So this is also a hint: if you basically create navigation systems, never try them where people know where they are. Do your user studies in another town, then people like it much better. And I think this is a bit, if you tell people what to do, it is really easy to impact their behavior, to predict their behavior. And this is not new. If you build a street, people use it. If you provide a path, people will go along this path. And whenever you build technologies, you cannot not manipulate people's actions. You will always manipulate what people do. And I think we should accept that we do that as scientists, as engineers. We will always change what people do through technologies. And there's always the question, it's a fine line between manipulation and intelligent assistance. And I give you one example. So imagine you build an interface, an intelligent interface that gives you recommendations for how you should travel. The first version says, take the train at 12:17 from platform 6. And if you do it like this, people will probably say, and we did this in a different context, I don't want to feel like a robot. I don't want to have a system tell me what I'm doing. You could also use version 2. Which one do you want to take? The train at 12:17 from platform 6 takes 45 minutes, or the bus 12:15 from platform 3 takes 50 minutes, is unreliable. The outcome will be the same. People will take the train at 12:17. But the second one, people feel much better. Is this okay or not? I think that's a really open question. And you will manipulate people with intelligent assistants. And I think we see this now with things like Alexa. When you order things, obviously will tell you what they make money on buying. And I think you see it, how things are ordered on Google, etc. And so it's really an interesting point. As intelligent agents are not perfect, they typically hide a lot in the interface. And I think as you see this, there is really a fine line between being manipulated and receiving assistance. And so the question is now, what do we build? Do we build something like classes or a binocular? And I think this is, again, taking us to a higher level. And I think the higher level question is really here. The classes is something, I'm not sure who of you are wearing glasses. I can see a few of you are wearing glasses. If you wear glasses, you did not think during the whole talk that you were wearing glasses, but now you're probably aware of it because I mentioned it. And I think this is a great technology, and we want to go for there. But I think very much the app world we see at the moment is much more the binoculars. We use them when we need them, we put them away. We use them when we need them, we put them away. And I think what I would want to build are technologies that are much more on this, the level of classes, things that fade into the background, that really make me, understand my environment better without me realizing that I use technology. And there are a number of papers on that. And I think that's in a way the question. And I think there is this, it's the question, the partner, does the computer choose my partner in the medium term? And I think you could take things like very simple. If I give you a space on the train and I always put you next to a certain person, you may get to like that person, you may get to know that person. And I think at the moment, a lot of those things are random. Once we have AI built in, they may be much less random. And the final project I will only quickly touch on because I think we're out of time. I think we have roughly an hour, I think my timer says. So we looked into images and image recording, but the interesting thing what I want to take here is if you have pictures and you have stored them in a system. And what you see here, this is just a standard Windows screenshot from my pictures. And Windows chooses one picture to let you peek into the folder. And what happens with that picture? You will remember that picture much better than all the other pictures. Why? Because you see it much more often. Every time you open your pictures folder, even if you don't go in there, you see that picture. So you revise that picture. And now the question is, let's assume you were on a holiday. Which picture do you want to have here? Typically, you don't want to choose which picture is in there because you don't really care. But at the same time, you don't want to have somebody who has something evil for you in mind to choose that picture. And then there's the big question. I think we wrote a bit about this. Who do you trust to manage your images? And it's really this very simple thing. Who you trust that they show it in a way that is sort of random, that they don't show it in a way that you are booking this holiday again, or that you want to buy something specific because you see it more often than not. Who do you trust? And in the end, I guess sort of we are not necessarily trusting the big companies that are hosting our cloud services at the moment. And I think for the pictures, you can argue this is really a small issue. But I think if you go a bit further, who do you trust which movie you want to watch? Do you trust Netflix that they have the best interest, that they show what's most interesting for you? Who you're sitting next to on a plane? Which way you walk, and basically by this, which shops you encounter, which are the people you encounter, which neighborhoods you encounter? Who is in the same restaurant as you? And I think the same restaurant is an interesting part. Obviously, once you are Yelp, you could really bring people together, or you could manage that people see each other never in a restaurant. At the moment, they don't do it because the algorithms are not there. But once there is a business case, we'll see that. And I think this goes all the way down to, if you talk something, if you look at things like matchmaking tools, and I think we have seen now that it approaches 50% of people meet people online. Who do you trust? What is their interest in bringing you together? And I think this really asks the question about the infrastructure. And there is a quote by Winston Churchill. He says, "We shape our buildings and thereafter they shape us." So buildings make how we interact with people. And I think what I would argue nowadays, we shape our intelligent infrastructures and thereafter they shape us. They decide who we going to marry in the end. They decide who are we going to meet. And I think we are in the middle of it. And the question is really, who shapes these infrastructures? Who is the we? And basically the we should be us and not necessarily a small set of corporations. And I think once it's in the infrastructure, you cannot opt out anymore. Opting out from a mobile phone is really hard at the moment. Opting out from Google Maps, if you live in a bigger city, is really hard. And you may choose between 1 or 2 or 3 providers, but in the end, a lot of the infrastructure is required to live the life as we live it. Hence, we want to have more control. Hence, the definition I have put up, that we really want to have interactive artificial intelligence that is human-centered. And the final word, coming back to what is reality? Your perception and interaction shapes your reality. What you see, what you interact with. And as soon as this becomes digital, it's basically down to human-computer interaction that we are shaping the future world. By creating the interfaces, we really shape people's reality. And this is a huge challenge, but also I think a huge responsibility not to create a rubbish future, a rubbish reality, that we create a true reality people like to live in. And I think with this, I'm done, and I'm acknowledging sort of the people who spend money on our lab and give us the chance to do research, the European Union with the ERC, and also the German ministry. Thank you, and I'm looking forward to some questions and discussion.
Thank you so much for the amazing presentation, Albrecht. We are now open to questions, and it was a very thought-provoking talk. So I am expecting us to have at least.
And I look for disagreement. I really look for disagreement. So because I think some of the things are really scary. So I would hope that there is sort of some people who say it's not coming that way. It will be all different.
Does anyone want to start with any questions? Maybe I can just like kick things off with some of the thoughts that I have from the slides that you shared. So it was overall really interesting to me and very thought provoking. I feel that a lot of what you shared about the interactions between how humans are with the AI today actually can be reflected with how humans are in general throughout time already, or just how we are in general. For example, when you showed about how technology manipulates and how there's a difference with intelligent assistance, and I was thinking that every one of us is manipulated in some way the moment we are born. You could say that we are manipulated by our parents to be who we are today, but of course, let's not use that word. Let's say we are intelligently assisted by our parents to be who we are today. And then, it's the
But
same
once
as how
you're a
we interact with
parent,
machines
you understand that you
afterwards.
manipulate. Sorry.
Right. Yeah. And it's also it depends on the sense of benefit as well. We know that we don't feel we're manipulated as much by our parents because we know that what they do benefits us for our future, at least in most cases. Whereas in the situation with big companies like Facebook and Google, somewhere deep down that they are doing it for themselves as opposed to for us. So I think it does depends on a lot of how we believe the benefit lies, as well as another thing as well, that another example besides the manipulation is the part where you mention about the parking example, where how we try to um distribute the lower level task, because we know we want to park somewhere and we tell the machine that we want to park there and they do the rest of it for us. It's pretty much how big companies, or even how we do a lot of our works, like in the CEO of a company, they can say that they it's not like they know every product that's being released in their company, and because they are not the actual engineers working on it, engineers or developers or designers working on it. The actual engineers and developers, they are the ones who did all the hard work and working and developing the actual product. But the person who is in control is the CEO in the end. And if he says he lets on a decree saying that no, you cannot do this, you can't do it. So in the end of the day, if you have the higher level sense of agency, even if you're not in control of the exact moment and time for that specific task, you'll be fine with it. You know that if you didn't like the parking, you could take over. But if the technology didn't allow you to take over, to assume direct control at that point, then perhaps you wouldn't be very comfortable with it. So just some of my thoughts that I was sharing. It's not really a question, it's just more like my thoughts. Maybe I can like kickstart something.
But I think I really like that point, the question of whether we should be allowed to take over or not, which you brought up. And I think this is something where I think also in for example, the car industry, there's a big discussion if you should have to take over or not. I think, and there's basically people have argued that you want to have the human not in the loop, and others argue that you really need that sort of ability to change the level of control, or the granularity of control, that you go from the CEO style to really the person who does it. And I think it's also, I think one topic I didn't really raise is sort of the de-skilling or reskilling. I think a lot of people who see it negatively say it's about de-skilling. And I think you get this with pilots. If they get automated landing, their landing skills get down. But I think the whole evolution of mankind is de-skilling and reskilling. I think many of us would probably do very poorly if we have to live the life of our 100-year-old ancestors. We would be probably starving a lot and probably freezing a lot. And so the question is, but we have learned other things. So the question is that the skill profiles, how we change them over time, and how this goes together again with AI, I find also a quite fascinating area.
We have a question from Gun actually. So he says, would the world ultimately end up all we need to say to the computer is no thanks, as it will take care of everything? Will you mind elaborating that a little bit more, Gun?
Yeah, sure. Thank you very much for the very interesting talk. I think ultimately, if we kind of extrapolate extremely, I think AI will basically know everything what we will need and even proactively work out for us. So I think if we put that into extreme case, I think we might end up just saying no thanks in very rare cases, while AI will take care of everything. That kind of sounds very pessimistic in terms of HCI researcher. We don't have to, the ultimate interface will become basically no interface. You don't really have to worry about the details of how you interact with the computer anymore. So my question is around, do you think the direction is heading towards making people to less care about or less worry about the things, so that ultimately you might end up needing to do nothing, or is there another vision or direction that you would like to envision?
I think I would not call it pessimistic in a way. I think sort of when we wrote intervention user interface, that was obviously one of the discussions we had. We didn't put it that strongly in. I think we put sort of an an interactive spin to it, because we still think it's not just no thank you, it's basically, oh no, different today. But I think we see probably certain areas where you really don't care. Things like the heating system in your house, for example. It's probably something, once this works well, you will even forget that you have one. I have seen this now with light switches in the apartment building I live in Munich. They have installed automated lights and they work extremely well. They have a lot of sensors and basically it's on the outside the flat and in the staircases, and it works extremely well. You don't really think even about the light anymore. And I think the switches have gone completely, so the interface has gone. So I think we'll see certain areas, and I think it has to work perfectly. I think this is sort of the tricky thing. If it works 99%, that's not good enough. I think this is sort of the thing where it becomes an interesting question. So I would guess we will deal with challenges of sort of these rare cases where we have to have the interventions, and they will be really hard to solve nicely, because you have to think that you haven't used it for a while, the de-skilling. So you haven't used it because the last 99 times it worked well. And now you have this one case where it doesn't do what you want. How do you communicate what you can do? How do you make it really easy for the person to do it? How to make it a good experience? How to make it in a way that the system can learn from your interaction that it next time gets. So I think that it's a bit like the control thing. We're shifting to a different thing. So we probably don't do boring interfaces for tasks that can be automated, but we probably do very challenging interfaces for very specific tasks that are very rarely done. So this is the positive take on why we should still educate people in HCI.
I see. So if I may kind of follow up with that, I think your analogy regarding controlling lights is very clear there. So I think as an HCI person, I think we should shift our focus from designing the light switches to how we control the lights to serve them best, the users. Probably, maybe that's what I get from your message there.
And I think it may be much more implicit than explicit. So it may be not the light switch you press, but you design basically what sensing you have, when it should be on, when it should be off, the curve it's fading in, fading out. So I think we get probably much more interesting interfaces that are not necessarily the button, but something much that I completely agree. I think that's and that's why I think the challenges are not going away, I hope.
Thank you.
Great. The next question is by Dennis.
Yeah, so I'd like to hop on a bit on what you said, Pi. It made me think when you were talking about control. So who is in control? Is it the driver or is it the CEO? Or will it be always us? Or I'm a bit unsure. Like you said, you encouraged us to be a responsible designer, to design the future so that's a future we would like to live in, right? But once we apply an AI, or let's call it a self-learning, machine learning algorithm, there are decisions being made which are beyond of our understanding. They are automated decisions, and which are really hard to understand. Nobody understands a neural network. Nobody understands why Amazon recommends me a spy camera. And I guess, and I bet even Amazon and the designers have no idea. And so how far is our responsibility when we deploy AI, which we are actually unable to understand by ourselves?
I think that's why we put into the definition. I think if we don't understand it, we should not deploy it. I think if we don't understand the benefit of it, I think obviously Amazon has a very clear understanding. I think that's sort of, they may not understand why you get a camera suggested, but they have a very clear understanding. With this algorithm, we increase our sales. And I think that's already knowing this is something which is probably helping you to understand it. And this is sort of the Microsoft example of the chatbot. I think it's probably, it is irrelevant how their algorithm works, whether they use a 100-layer neural network or if they use a rule-based system. I think you don't care in the end. I think, but if you understand, they suggest this because they have indicators from your behavior that you're going to buy it and that they make more money on it, you probably have a very different perception of this recommendation than if you don't know why it's there. And I think so that the question is really to make this transparent, why things are suggested, and not necessarily how they are suggested. At the moment, we focus very much on why did they come up with the spy cam? And I think on a higher level, I think what's interesting to the end user, who will typically not understand the algorithm, is they're suggesting because their algorithm is built in a way to maximize what they sell to me. So this may look attractive to me, and that's why they suggest it to me. And I think this may be for a lot of users already something which I think seems trivial in a way in that case. But I think we looked into things like, what is the design objective of TikTok, for example? I'm not sure if you have tried it out. So the design objective is very clearly that you are not going away. I think there are a lot of things we have now looked into, things where you basically sink a lot of time, where you basically just waste a lot of time. And I think this is sort of Instagram, etc. And if you look into a lot of the small design decisions that are made, they are sort of from the persuasive computing side. I think there have been a lot of publications. You can find a lot of those things. I'm not sure if they read it or they're just obvious to do. I think it's really these things that you get sort of this nudge to stay, to watch the next bit. The next bit is even better than the last one, etc. So they made a lot of decisions. And I think if you would have now already, when you start this application, it would say, look, this is application, this is designed for you to lose sleep. This is sort of, we give it to you that you use it in the evening and you will not sleep for 2 hours because you're hooked to it. This would already be the question if this helps or not, but I think it would be from a designer perspective to really say, what have you got, what did you do in order to optimize your system?
So one thing you say is important as a designer to be transparent about our design, or we might not understand it. I mean, it's hard. I mean, this technology that is now surrounding us is on the one hand opening so like many new opportunities, but also has and yields risks in all fields, and which we're not thinking of yet.
And I think that brings me back to the materials. I think when these materials, be it iron, be it bronze, when they came into societies, explosion of applications in a way. I would call it, so basically now, and they have always, I think, you can look back in history, there are a lot of wars that go together with new technologies. Once a new technology is out there, people have not just made cooking pans. I think this is sort of, and you can see this through history, that a lot of inventions have given some people the feeling of they can have an advantage by applications they build. So I think this responsibility and this risk is real. It's not a hypothetical thing.
So do you think there will be an AI war?
I think it's probably already
AI, maybe.
It's probably already
we have
happening.
companies competing. Yeah.
And I think also, if you, I give you one example which I found quite interesting. So because Apple and I think that you could take Amazon, they are the size of these companies is huge, even compared to smaller states. So their turnover, and so on a European scale, the amount the European Union invests in research and development through their frameworks per year is the same amount of money Apple, a single company, invests in R&D every year. And if you look at sort of, if you don't know the European budget, it's basically, there are 800 million people and public research funding is big. And it's basically research funding from medicine to space science, from computer science to green energy. Basically all the public funding has the same size per year as a single company, Apple, can invest in a very narrow slice in basically mobile devices, perhaps cars, perhaps buses. And now basically this is already such an inequality. So this level, what we have there. So who can compete once the companies have become so strong? Because their means for innovation are huge. And I think this is sort of one of those things where I think this war has already begun.
Yeah, I agree.
Great. So actually, I already have several questions lined up here until the end of the seminar. So maybe no more after this. So the next will be by Suranga.
Thanks for the really interesting talk. It was very enlightening. You did mention that how technology has enhanced our capabilities and in fact even going to shape the reality. What about the situations where when these new technology systems doesn't work? For example, now if my phone goes dead, I don't even remember a phone number that I could pick up a public phone and call somebody. Have you been thinking about those situations, and as HCI researchers, designers, should we also be thinking about that as a critical part to make sure that we can still do stuff when these things fail?
I think it's a really interesting point. So 2 weeks back, I memorized our home phone number again. So basically, I just didn't know it anymore. And I was out skiing, and I was tracking my cross-country skiing, and at some point the phone was dead. And I wanted to be picked up, and this is really annoying. And so I basically skied home. That was just 5 kilometers more. But after this, I basically memorized our home phone number again that I could have asked just somebody else to call. And because I realized I'm completely relying on it. And I've been sort of multiple times arriving at the airport, not knowing which flight I'm going to take. And I look it up on the phone. But I think this is, again, it's not new with current technologies. Who of you could survive without a supermarket? Who of you could, and I think I've done some survival training some years, some 20 years back, and I like the outdoors. So I think surviving without sort of the whole infrastructure we have in cities is really hard. So basically, if electricity goes down, how many days can you survive? And so basically, it is not, and I think the washing machine, etc. So I think it is something which gets probably a new quality, but we have accepted as humans in order to advance our society to do this. And I think if you have something like big cities and you look at the scenarios, what happens if you run out of power, if you run out of supplies, this is horrendous. And I think everybody is building stuff in place. And I think what I learned from this, I'm not planning for it doesn't work, but I want to build systems that are resilient. And I think this is something we, as also from an HCI perspective, we have to look more into, not just basically building something that works a bit, but really thinking now, if we think of things like big augmented reality, and we know that at some point augmented reality is part of our human memory, basically that we cannot really work without it. We have to build it in a way that it's really reliable, that it's resilient against people trying to take it down, because that's the other thing I think we've seen now, that people have attacked infrastructures. So I think this making things more reliable is a very key thing, because I think we cannot live without them. And I think if we look at infrastructures like the power grid, which is, I think, for most societies highly critical, there's a lot in most countries in place in order to make this really hard to attack and to make it very, very stable. And I think at the moment, the same thing is if infrastructure, if internet goes down, I think in Germany, there have been estimates that for 2 days this can work, but then you have like a huge chaos, because I think this is sort of companies, there will be a lot of problems that are to a point that you get sort of civil unrest, etc. So I think this is sort of something where we just add more to the mix, and hence I think the responsibility is in making things more robust and more, better in a way that they hold out.
Thank you. Thank you so much.
Great. And our final question for today will be by Charmaine.
Hi, thank you for the amazing talk. So in the talk, you're mentioning that we need to augment these AI technologies more with more in human-centered manner, and especially those applications, making them smoother and stuff. But I would like to ask, what about, is there like any way we can augment these machine learning models or algorithms in with more human bias? Or is it possible, but like to add more human-centered aspect to algorithms? Because I feel like today the algorithms are very much data hungry, and they are very much billion scale, so they are not that rule based anymore. So I'm asking, is there any possibility that people will try to make algorithms that suits better for human needs, or people will still go with algorithms that work with data, that work for data?
I think sort of if I got it right, so I think it's an incentive question. I think basically what you build, because we could build, as I understand it, we could build both. I think we have a lot of choices what we build, but at the moment I think companies as well as individuals will build algorithms that are sort of that bring benefit to them or to their company. So I think the question is, how much do we regulate? And I think if you look at Europe, with a lot of Europe has a lot of traditions of regulating what you can do and what you cannot do. I think the data privacy things are just the last ones. I think other countries like the US, they have sort of a very open thing. So I think the question, what we build, is probably not limited by technology. At the moment, we may feel it's still limited by technology, but I think in the medium term, we can build whatever we want if we have the resources to build it. And we will probably go mainly for the things we see an advantage in. And I think that brings me also back why we say basically we want people to state what advantage they design for. Like, what does Google design Google News for? What is their, and they sort of like, if you do a medical device, if you do drugs, medical drugs, you have to tell what they're good for, what the risks is. And I think in most countries, if you buy drugs, there's sort of a very short piece of paper in there, which is readable. I think in most countries, it's now readable by sort of also an average person, not just a doctor. And it says what it's good for, how it's to be used, and what the risks are. And I could imagine that sort of talking about the algorithms, that we have to state those things, because we cannot really limit this. I'm not sure if I got your question right. Did I sort of get into the right direction?
Actually, yeah, but I mainly wanted to know, like, whether, like, because we are going to develop these machine learning algorithms also, right? In the future, it is going to get developed. So what I'm asking is, like, so when especially if you take neural networks, it's really hard to explain what is happening inside, right? And I don't think it is going to get possible to explain every aspect of it in the future, because they are getting bigger and bigger. So how you align this with this human centered computing, like
And
these
I
different
think we
types of
have to, so we have to find different explanation models. I'm not believing that we can explain them in the whole complexity, as you said. I think they're just too complex that we can. But I think what I think we can sort of on a high level give explanations what they do. And I think that's brings me back to sort of basically, let's say Google has an algorithm that chooses the news you get. And I think it's probably for you interesting what they have optimized the algorithm for, rather than what the algorithm is. If they tell you we have optimized it for that you get at least 5 different areas, that it's relevant to your current location or the location you have been in the last 5 days, that it also links to advertising they want to sell you, etc. If you have these points, you may be understanding what the algorithm does, even if you don't know whether it's a rule-based system, a deep neural network, whether it has 50 layers or 400 layers or just 3. So I think having this, what they have designed the algorithm for, what they have trained it for, basically what was their training function, what it is the optimal algorithm they were looking for, I think that may be a much better explanation than the source code or the actual thing, because as you said, the complexities of the algorithms, we're just at the beginning, they go up. And so I think we have to find another way to go there.
Yeah.
And I just, if you basically want to look up some of the points we published, it's not a real, not a big paper. It's just a very short, a 4-pager with the definition. And as I said, we put this out in order to challenge. And I think we don't believe this is sort of the right definition, but it's one definition. And I would be really happy to be challenged on that, also the properties. I've just put the ACMDL link out there in the chat if you're interested in downloading the paper, and then really getting more discussion going.
Yeah, thank you very much.
Great. So I think this brings us to the end of our seminar for today. If there are any other further questions, I think you can just directly direct it to Albrecht. I'm sure he'll be glad to answer you. Otherwise, you could also send me a mail. I'll forward it to him as well. So thank you so much, Albrecht, for sharing your work with us, as well as your thought, as well as everybody here who is attending the seminar, maybe some really late, some really early. And I do look forward to the next seminar, which will be shared on our social media, Facebook page next week.
Thank you so much for having me. Thank you. And if you're in Munich, please drop in. If there's sort of, I think the world back to normal again.
Great. All right. So that's the end of time now. Thank you, everyone.
Bye-bye.
Have a great day ahead or great evening ahead. Bye. See you.
Thank you very much. Thank you.
Good night.